So we're going to look at solving linear systems. And we've been given two bank accounts. So our man Dan here's got $500, right? And he wants to put money in a savings account. And these two options were Save-A-Lot and Maple Leaf Savings. And Save-A-Lot charges $10 per month and 75 cents per check, while Maple Leaf Savings charges $7 per month and $1 per check. Now this can be confusing because it looks like both of these are variable, right? And if we were to set up linear equations, we're used to when they explain a linear equation, they say something like, sorry, I just need a page. Here we go. When they talk about y equals mx plus b, they usually refer to b, which is our y-intercept, right? We're okay with that. They usually call that a fixed cost. Okay, that's usually known as a fixed cost, which essentially, even if you do nothing, you still have to pay that amount, right? And our m, which is our slope, that's usually known as our variable cost. So it completely depends on how often we ride the bus, or we use this service, or we buy this many of those. That's our variable. It's very dependent, right? But in this question, it really looks like we have two variable, right? Because they're per, right? $10 per month. 75 cents per check, $7 per month, $1 per check. So it almost looks like we're stuck with two, but we have to try to think of this in more of a real life situation. Okay, if Dan's going to put his money in the bank, okay, he's going to have to pay a fee. Okay, and he's going to have to pay that fee, it looks like, on a monthly basis. Okay, so though the amount of months he keeps his money in the bank could be variable, maybe he'll say he'll only keep it for 3 years. Most people keep their money in the bank essentially forever. That's the idea, is to keep that money in the bank forever, and then there's going to be costs on top of that. So what we're going to do is, instead of looking at this as a long term, we're going to look at this on a per month basis. Okay, so he puts his $500 in, and we want to know in the month which will be the better of the two systems. Okay, so in other words, no matter what he does, he's going to have to pay $10 if he does Save-A-Lot, and he's going to have to pay $7 if he does Maple Leaf Saving. So this per month thing isn't really important, okay? Because we're going to compare it on a monthly basis, okay? So he has to pay $10 and $7. So we're going to build, two linear equations, okay? If this is no longer, or this is a guarantee, a fixed cost, what would that be in terms of y equals mx plus b?
dx.
Hold on a second, let me get this. Let me write these two out. Y equals mx plus b. Okay. So remember, when we're looking at these two equations, we're essentially trying to figure out which is m and which is b. And we have our fixed cost here, and our variable is also our y-intercept and our slope. So since our per month cost is no longer important, okay, it means we're going to have to pay that no matter what. Do you think that means that's the variable or that's the fixed cost?
The fixed.
Yeah, that's going to be our fixed cost. So in other words, our per month thing, again, it's our fixed cost, is going to be $10 for Save-A-Lot, and our fixed cost for Maple Leaf Savings is going to be $7. So that's going to be the y-intercept for both. And we'll just kind of move this over here so we have room. Okay, so for Save-A-Lot, I guess we'll do it in, we'll try to do it in red here. Y equals mx, and then our fixed cost is, well, we got to pay that $10, so positive 10. And for Maple Leaf Savings, we'll do in blue here, y equals mx, and they got to pay $7. Now the variable cost. The variable cost, obviously from the information we have left, is our checks, right? I could write 1,000,000 checks in a month, or I could write 0. So this is really going to be dependent on how many checks. So this is something I have control over. Okay, so this is going to be what's left to solve, essentially.
The m.
Yeah, the m. This is going to be our variable cost. It's also known as the slope of the equation, right? So we're going to use this value to replace m in both of these equations. So we're going to go ahead doing that. And again, I'll move this so we have room. Color mine blue. Okay, we'll do blue first. Y equals, they had a $1 charge every time, so that's 1x. And just quickly, do we have to include 1 times anything? Like we have 1 times x? No, because it's just going to be x, right? So I'm going to rewrite it as y equals x plus 7. This is a simplified version. And then in our other example, it was actually 75 cents, so 0.75, which we do need to include x plus 10. So here are our two comparisons. We're comparing these two, right? This is our Maple Leaf Savings, and this is our Save-A-Lot. Okay. What we'll do is we'll compare them graphically after, but what we're going to do first is algebraically, we're going to solve for x and y, which will be the point of intersection. And the point of intersection of these two lines, so let's kind of hypothetically put this up, right? This guy's at 10, so he'd be here, and he's kind of got a lower slope than this guy. He'd be at 7 with a steeper slope. What are we solving for when we look at that x and y?
The point of intersection.
Yeah, the point of intersection, which means cost-wise, that's when they're what?
When they're equal?
They're equal. That's the point when it doesn't matter which one I choose. Okay, excellent. So let's go about solving these two. Okay, so I'll call the first one equation 1. So y equals 0.75x plus 10. That'll be our equation 1, and our equation 2 here is y is equal to x plus 7. So, how do I do this? Are you used to substitution, elimination? Which one?
We've done substitution today.
Okay, so let's work on substitution. When we're doing substitution, you essentially want to set one of the equations equal to a variable. And luckily, we already have that in equation 1. Everything is set equal to y. In other words, I can replace the y in this equation with all of this info right here. Okay, all of that can go substituting right into it because this is replacing our y. Right? So we're going to replace y with that value. So what this now reads is, instead of just y, so we're plugging it into equation 2, 0.75x plus 10 is equal to x plus 7. Does that step make sense?
Yeah.
Maybe I'll put it in red here. That wasn't the nicest. But okay, so that's where we replaced the original y. There used to be a y there, we replaced it with this. Okay, I should have left it in black now, it's hard to read. We're going to collect our like terms, okay? So what I'm going to do is I'm going to move everything that's a variable attached to it to the left and everything that's a constant to the right. So 10 is a constant. When it comes over to the right, what will it become?
A negative.
That's right. So we have 0.75x is equal to x plus 7 minus 10, right? We'll do the color each move, okay? Which means I want to move x to the other side. When I move x to the left, what will that become?
A negative.
Yeah, so how do I write that?
Minus x.
Yeah, minus x, exactly. And what number is technically in front of that x?
1.
That's going to be important here because we have a decimal. I want you to keep that in mind as we go through this, okay? Minus x is equal to 7 minus 10, okay? So let's do all of the equating. What is 7 minus 10?
Minus 3.
Yeah, negative 3, great. Here, 0.75 minus x minus x. What are we looking at here? When we subtract variables, what do we focus on? Do you know what they're called? The number that's attached to the front?
Coefficient.
That's right, the coefficient, right? So this coefficient is technically 1. So let's focus on this. Really what this says is 0.75 subtract 1. Okay? Do you know what that is off the top of your head?
Negative 25.
Yeah. Negative, and not 25, but 0.
Oh, yeah.
Yeah, 0.25. But you had it, I know you did. So 0.25. Is that it? It's okay like that?
With an x.
With an x. Excellent. Great. The goal is to isolate for x. So what do we have to do next?
Divide by 0.25.
You know everything. 0.25. Okay, let's bring up I have a new calculator, but it crashes. Let's see how this works. Clear. What are we bringing up? Negative 3 divided by 0.25. I can't make this smaller. So 3, I make things negative on my new calculator. I don't know. How annoying. Okay, anyways, let's do this. Since my calculator doesn't know it, I'm dividing a negative by a positive. What does that mean my answer is going to be?
Negative.
It's going to be negative. So I'll write them both in as positives, but I have to know that my answer will be negative. 0.25. Answer is 12. So is it positive 12?
Negative.
Negative 12. Negative 12. So x is negative 12. Are we done here?
No.
And this is really odd. Ah, here's our mistake. I was wondering, I'm like, that doesn't make sense. When we subtracted, this should have become negative 0.25.
Oh, yeah.
Okay, so when it comes over, it's negative, and two negatives
Equal
are
positive.
a positive. the reason I knew we made a mistake, which was good, is because if I wrote negative 12 checks, that meant we were our break even, which really doesn't make sense. So I knew there was an error. It was good. I was able to go back and correct it. So now we know it's at 12 checks. That's where our issue is. Now we take that value and we can plug it into either equation 1 or equation 2. Equation 2 looks like a simple one, so let's plug it into that one. Okay, we use equation 2 again. And y is equal to, this time we replace x. We know x is 12 at the break even, plus 7. So what is y? We have 12 plus 7 here.
Oh, was I supposed to answer
That's
that?
okay.
Sorry.
19, right? So what that tells us is our coordinate is when we write 12 checks, we'll be spending a total of $19, including our upfront fee. Okay? And that's when they're even, the two things. So without plotting these, and I am going to plot them in a second, we'll rewrite the two again. We had save a lot, and Maple Leaf Savings. Y equals 0.75x plus 10. Y equaled x plus 7. And we knew at 12. Okay, so the point of 12, we knew that these two lines were crossing each other. What if I decide I'm going to write less than 12 checks? Who's better? Can you tell? Maybe we should graph it. Want to graph it?
Yeah.
Okay, let's graph it. So here's a great little graphing program. Okay, it's called Desmos. We won't be using any of these things there. But our two things here, so we typed them in. 0.075. Oh my gosh, I'm not typing anything. Here we go. 0.075x plus 10. So this is, and I'll zoom out just a little. Here's our first company. Purple is our Save-A-Lot. Our second company was x plus 7. And really, I should put my y's in, because that's mathematically correct, right? We were right. It's at 12 and 19, okay? Now, orange represents Maple Leaf Savings. So, before 12, orange is below, which means what?
We spend less.
We spend less. So, who's better between 0 and 12 checks?
The Maple Leaf.
Maple Leaf. And then after 12 checks, it makes more sense to go with the
Save-A-Lot.
The Save-A-Lot. Okay, and that's what exactly this is. And we could have kind of deduced that by thinking of this idea. This had a 10 y-intercept, so he was a little higher. 7 is a little lower, but he was steeper, his slope. So he was going to gradually increase, and once he caught, he would be above. Okay? Does that kind of make sense?
Yeah.